Hello friends and welcome at my channel. Today I would like to tell you something about trigonometry and we move on. We are discussing the basic idea of tangent. Okay, so let us see how it's defined and maybe why it's called this way. So if we look at a function, curve, something like this, we can put a line which is just touching the curve. To touch in Latin means tangere, and the curve which is only touching the line which is only touching the curve is the name is tangent line, as you know. So we put a tangent line. Now you see similarity to the idea of the tangent. So this line is crossing the x-axis somehow at this angle of, let's call it alpha. All right, so we have two arbitrary points, let's say this one, and we don't necessarily need the intersectional point. We can take also this one. So we just have 2 points. This is point A with x2 and y2, and this is point B with x1 and y1. And now we can also produce a rectangular triangle looking like this. All right, 90 degrees in here, and we call it L, coming from here up to that point. All right, so let's call it A, and let's call it small b. So we have a right angle triangle. This is the corresponding angle, so this is alpha as well. So what do we have? Well, first of all, if we want to compute the slope of the blue line of the tangent line, it's m. It would be equal to b divided by a, or y2 minus y1 divided over x2 minus x1. Okay, just keep it in mind. The distance between the point B and the point A is capital L. We're also in the topic of trigonometry, so let us see how the sine of alpha could be defined here. Well, that would be B divided over L, and the cosine of alpha would be A divided over L as well. And now, as you can see, if we are considering, well, just by coincidence, of course not, but let us imagine, pretend that would be true, a sine of alpha divided by cosine of alpha, that would be B divided by L divided over A divided by L. That would be B divided by L times L divided by A. We can cancel the L's, and that would be B divided over A. As you can see, it's the same as the value of M. So this is the sine of alpha divided by the cosine of alpha is the slope of the tangent line. That's why we call this one tangent of alpha. That's the story. And now, of course, we can ask ourselves, what is the graph of the tangent? Okay, how could we produce this one? Well, let us produce once again the sine curve, minus 90, 90, 180, 270, and 360 right here. So we are going like this, right? So that's the story. This is the sine curve, sine of x. What about the cosine of x? Well, that goes like this. Okay, just continue the same way. 90, 180 degrees, 270, and 360 degrees everywhere, of course. Not working with radians. And as you remember in the last video, we proved that would be the cosine. And what we see is that the cosine, well, periodically from time to time is becoming 0, which means if you look at this definition, we are dividing by 0. That's not very nice to divide by 0. I hope you know that. Otherwise, check this video and, well, see what's happening. Well, tangent of 0, that would be sine of 0 divided over the cosine of 0. That would be 0 divided by 1, and that's for sure, let me move around, that's for sure 0. Okay, Okay, what about tangent of 45 degrees? Well, if you remember the sine of 45 and the cosine of 45, they were equal. We proved that in our last video, so that would be 1. What about tangent of 60? That would be sine of 60, again, divided by the cosine of 60. The sine of 60 would be what? The sine of 60 is, well, we're having square root of 3 divided by 2 divided over a half. So that's just square root of 3. And the tangent of 30, well, that would be actually the sine of 30 divided by the cosine of 30. So that would be sine of 30 is a half, and cosine of 30 is square root of 3 divided by 2. So that would be 1 divided by the square root of 3. But what is happening at 90? Well, this is where the first trouble is coming. Tangent of 90 isn't defined because we would be dividing the sine of 90, which is fine, and 0, by the cosine of 90, which is fine, sorry, the sine of 90 is, my bad, the sine of 90 is 1, and the cosine of 90 is also fine, but is 0. We're dividing by 0, so we're in trouble. So that means here, and of course because of the symmetry of the sine and cosine curves, we are at minus 90 at the same value, or the same kind of trouble. Let me show it to you. So the tangent is an odd function. Why is that the case? Well, what is f of minus x? This is tangent of minus x. That means we have sine of minus x divided over the cosine of minus x. If you remember, the sine is an odd function, the cosine is an even function. So we're having minus sine of x divided over the cosine of x. Okay? Is that the same to f of x? No, it's not. So it's not f of x. So tangent is not an even function. But what about minus f of x? Well, that would be minus tangent of x. And you see, that's exactly minus sine of x divided by the cosine of x. So this is equal to f of minus x, which proves tangent is an odd function, which means if we're having trouble at 90 degrees, we should be also having kind of the same trouble at minus 90 degrees. You will see why. So tangent of 0 is 0, tangent of 45 is 1. That means tangent of minus 45 at minus 1. So we're climbing high, as you can see. So at 90, we have a problem, and at minus 90 as well, because the cosine of minus 90 is the same as the cosine of 90. It's 0 again. So you see what's happening here? It goes up like this, and it goes down like that. So this is the curve of the kind of the main branch of tangent. And you see it's kind of repeating itself, because at 180 the sine is 0 again. We're dividing 0 by minus 1, so we're getting to 0 again. But then if we're slightly behind 90 degrees, so at 91, 92, we're still at 1, a bit less, but here we're negative. So we are infinitely large but negative, so the function goes like this. Well, with the limit at 0 going to, so like the slope at 180 should be 0, like this. Okay, and then we have many branches of the tangent, and it looks like this. All right, thanks for watching, guys, and next time we're going to do some more formulas for trigonometry. See you in the next video. Bye bye.